All right, so I'm live with 52 weeks of Swift, and I'm going to cover nested types today. And in order to do that, let me go ahead and share an entire window. Let's go ahead and do that. This would be, here we go, nested, entire screen. That's what I want to do. All right, so nested types here. All right, so the idea here with nested types is that enumerations are often created to support a specific class or structure's functionality. Similarly, it can be convenient to define a utility class for use within the context of a more complex type. So here's an example of a nested type in action here, where I have a blackjack card, which models a playing card used in a game of blackjack. And this structure contains two nested enumeration types called suite and rank. In blackjack, the ace cards have a value of either 1 or 11. The feature is represented by a structure called values, which is nested within the rank enumeration. So, right, we have a struct here, black card jack, enum, which is a nested suite enumeration inside of here. Ooh, look at this. Even Unicode is inside of there. So this is a very, very complex nested type here. And let's go ahead and build this out. So I'm going to copy that and I'm going to run it over here. And I'm just going to paste this into my playground. And let's see what happens. If I go ahead and I compile this, this does appear to work. Here we go, nested. All right, and how do we use this then? So the suite enumeration describes 4 common cards, and the rank enumeration describes the 13 possible playing card ranks together with a raw int value. And so we then can start using this. So because the blackjack card is a structure with no custom initializers, it has an implicit membership initializer. So you can use this to initialize a new constant called the ace of spades. All right, let's do that. Let's do one at a time. So we have first here, we have the ace of spades. Okay, and that's our blackjack card. And then we can print the ace of spades dot description. There we go. The ace of spades suite is that, and the value is 1 or 11. All right, so we've got that working. Okay, even though the rank and suite are nested within blackjack card, their type can be inferred from the context. So the initialization of the instance is able to refer to the enumeration cases by their case name. So referring to a nested type. So if you remember up here, this thing had a super complex nested type here. Rank enumeration was nested, and also suite enumeration, spades, hearts, diamonds, clubs. So let's go ahead and referring to the nested heart here. Let's try that out. So let's say let heart symbol equals blackjack card dot suite dot hearts dot raw value. Okay, let's try that out. So here we go. And we can see that's a heart. I guess I would maybe want to print that though, right? Let's go ahead and print this out. And let's say the heart value. And let's do that. Which would be hearts symbol. And let's put this into brackets like that. Does that look good? It does look good. And if I print that, the heart value is that. Okay. There we go. So we're able to print it out as well. And that's it. Okay, so that was a short lesson for today, but kind of fun to play around with also Unicode characters. That was kind of neat. But yeah, nested types. There you go. Not a lot to cover, but next week I'm going to cover what's next here. We would have, after nested types, we're going to cover extensions. These would be adding new functionality to an existing class, structure, enumeration, or protocol type. All right, so that is it for today. We'll see you next week with extensions.